Hi, my name is Miss Mackey, and I'm going to take you through notes for lesson 5.1 from the Blue Big Ideas textbook, the 8th grade Common Core book. Throughout the video, there may be times when I ask you to go ahead and hit the pause button to complete a task. After that task has been completed, go ahead and hit the pause button again and go ahead and restart the video. I'm going to take you through some vocabulary words, some key points, and then some examples that'll help you in the lesson that we're going to be doing. So, first thing I want you to do is this sheet was passed out in class today, and this is the note guide that you're going to use for lesson 5.1. The first thing I'm going to ask you to go ahead and do is I'd like you to turn to page 204 in your blue math book. I'd like you to find where the vocabulary is listed, and I want you to write down the definition for system of linear equations. In addition to the vocabulary word, I'd like you to include an example. Hit pause now and go ahead to turn to page 204 to get that definition. Now that you've done that, that first definition of systems of linear equations should be a set of two or more linear equations in the same variable. So the two examples that I have are a system of linear equations, y equals x plus 1 and y equals 2x plus 4. There are many examples that you could have. I included another one. So a system of linear equations could be y equals negative 3x plus 2 and y equals 5x minus 6. The next thing I'm going to ask you to go ahead and do is I'd like you to write the definition for the solution of a system of linear equations. I'd like you to hit the pause button, go to page 204 in your blue Big Ideas textbook, and write down what the definition for the solution of a system of linear equations is. Now that you've written the definition down, you should have written down an ordered pair that is the solution of each equation in the system. Pretty much it's the point of intersection. So we've gone ahead, and a system is a set of two or more equations, and the solution is the ordered pair that can be used to solve each one of the equations within the system. At the bottom of the sheet are the key ideas. There are 3 steps in how to go ahead and solve a system of equations by graphing. On page 204, I'd like you to go ahead and copy down what those 3 steps are. Hit pause now and copy down those 3 key steps. Now that you've copied down the 3 steps, let's review them. The first step is to simply graph each equation in the same coordinate plane. We're going to go ahead and use the y equals mx plus b form. Go ahead, plot the y-intercept, then go ahead and include the slope. You should have 2 ordered pairs or 2 points on your graph. Connect your dots. That should be the one graph, one linear equation. Then go ahead and do the same for the second linear equation within your system. The second step should be estimate the point of intersection. That estimate should be an ordered pair. The third thing you're going to do is you're going to take that ordered pair where the 2 lines intersected, and you're going to go ahead and plug them back into the 2 equations. Plug them into the first equation and make sure it's correct. Plug them into the second equation and make sure that is correct. Let's go ahead and try some examples. The first example is on the back page of this handout. We are going to be going ahead and graphing to solve the linear equation negative 2x plus 2 and 3x minus 3. The first thing they're going to go ahead and ask you to do is to identify the slope. The slope is negative 2, and if I'm using the rise over run, I'm going to go ahead and use that as negative 2 over 1. The y-intercept is represented by the b, and what I'm going to do for that is it is at b. I'm going to use that piece of information to graph. So my y-intercept is b. For b is 2, so I'm going to put a dot at 2. My slope is negative 2, which means my slope is going to be going downward. So I'm going to go down 2 over 1, and I can continue to do that to make my line longer. Down 2 over 1, down 2 over 1. It's important to use a straight edge when you're going to solve linear equations because you want to make sure that you're as accurate as possible when you're finding the point of intersection. So I'm literally going to use an index card, a ruler, a stick, something like that is going to go ahead and work. And I have just graphed one of the equations in my system. All right, and I'm going to do the same thing on the second one. I know my slope is 3, which is the same as 3 over 1. I know my y-intercept is negative 3. So I'm going to use those 2 ordered pairs to graph. So I'm going to put a point at -3 because that's where the y-intercept is. I am now going to go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. I'm now going to go ahead and use my straight edge to connect those dots to create a linear equation and graph that. Now, the second part of my key points told me to estimate the point of intersection. This is pretty easy to go ahead and tell. Where these two ordered pairs intersect is the answer. It's the solution of the linear equation, linear system. So my ordered pairs, my solution is 1, 0. So we've gone ahead and this is a system of linear equations. The solution to the system of linear equations is 1, 2. In order to check to make sure my estimate was correct and my lines worked, I'm going to take 1, 0 and plug it into both of the solutions to make sure they work. So I'm going to do the first equation, and that's going to be 0 equals -2 times 1 plus 2. And I have 0 equals -2 plus 2, 0 equals 0. So the ordered pair worked for the first graph. Or for the first linear equation. Let's work it for the second one. So this is 0 equals 3 times 1 minus 3. And this is 0 equals 3 minus 3, 0 equals 0. By checking the ordered pair in each one of the equations, I can guarantee that this is my solution. We're going to try it again. So we graph each equation using y equals mx plus b. You estimate where they intersect, and then you check it to make sure that the solution worked in each one by using that ordered pair where the point of intersection was. Let's try the next one. This one is 2x minus y equals -3. In order to graph that, the first thing I want to go ahead and do is I want to write it in y equals mx plus b format so I can go ahead and just use my slope and my intercept. So I'm going to go ahead and subtract 2x on both sides. Okay. Now I have -y equals -2x minus 3. I'm going to divide both sides by -1, so I have y equals 2x plus 3. My slope is 2, which is a rise or run of 2 over 1. My y-intercept is -3. So I'm going to take those, that slope and y-intercept, and go ahead and graph it. I'm going to put a dot at -3, which is right here, 1, 1, 2, -3, and then I'm going to go ahead and go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay. Taking my straight edge, now remember, at any time during the video, if you want to go ahead and try it before me or feel like you have a handle on it, go ahead and hit the pause button and see what you can compare your work. If you don't understand what I said and you need to go ahead and rewind, you can do that as well. All right, so now let's go ahead and look at our second equation. It's -4x plus 2y equals 6. I'm going to go ahead and I'm going to add 4x on both sides. I now have 2y equals 4x plus 6. I'm going to have to divide both sides by 2. I now have y equals 2x plus 3. My y-intercept is 3, and my slope is 2, which I can graph as 2 over 1. So I'm going to put my ordered pair, or my y-intercept at 3, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm going to go ahead and connect my dots. What do you notice about those two lines? Those lines are parallel lines. They have the same slope. So this is going to have no solution. It doesn't intersect anywhere. So there is no solution to this linear system. So let's review our steps. First thing you do is graph the first equation. Graph the second equation. Estimate the point of intersection. Write down what that ordered pair is. Plug it into each one to make sure that it solves both of them. let's move on to the next example. Here we go. Turn those notes over. And now we're going to go ahead and match the solution. We're going to be using a little bit about what we know about these equations to go ahead and help us find what the solution is. So I know this is my y-intercept. Right? So on which two of these graphs is a y-intercept? Okay, that has a -4 and that has a +3. This has a slope of 3, 1, 2, 3 over 1, 1, 2, 3 over 1. This has a slope of -1/2. So down 1 over 2, down 1 over 2. If you look, this is the point where the two linear equations actually intersect. So if I go ahead and have that point of intersection, the solution to my system is 2, 2. And I can plug it in to check it. 3 times 2 is 6. 6 minus 4 is 2. And the y is 2. So 2 does equal 2. And I can do it to the second one too. So -1/2 times 2 is -2 and is -1, and -1 plus 3 is 2. And so y equals 2. So I know I've done that. This has a y-intercept of 3 and a slope of 4. Up 4 over 1 or down 4 over 1, down 4 over 1. And this one has a y-intercept of -2. And this is going up 1 over 1, up 1 over 1, up 1 over 1. And you can see the clear point of intersection. If I connect my lines again, I can tell that my answer is -1, -1. The solution to this linear system is -1, -1. And I can plug it back in. 4 times -1 is -4. -4 plus 1 is, or -4 plus 3 is -1, which that's what y equals. And then I have the opposite of x, which is 1. 1 minus 2 is -1, which happens to be y. So we've gone ahead and graphed the two linear equations, estimated the point of intersection, plugged those points back into the equation, and then checked to make sure they solved both of them. The last part of your notes is going to be going ahead and using two equations to complete a table to solve the system of linear equations. So use a table to find the break-even point. The break-even point is where they're going to intersect. And this is simply just going to be a plug and chug because I have 25 times x plus 210. That's going to be 25 times 0 is 210. 25 times 1 is 25. 25 plus 210 is 235. Okay. And then for the r, you're going to go ahead and 60 times 0 is 60. 60 times 1 is 120. Hit pause. I want you right now to go ahead and complete this table. Now that you've completed the table, the numbers should be 260, 285, 310, 335, 360, 385, and 410. For the R, 60, 120, 180, what is that? 240, 300, 360, 420, 480, and then 540. Now, do you see any points in here that they go ahead and they intersect? I don't. Did I miss one? Let's solve. I have a point at 210, and I'm going to go up 25 over 1, up 25 over 1, up 25 over 1. Okay, so my ordered pair is going to look like this versus 60 that starts there and goes up 60 over 1, up 60 over 1, up 60 over 1. It looks like they're going to intersect pretty high up. 210 plus 25 is 235. 235 plus 25 is 260. 280, 310, 335, 36. Oh, here, I missed it right here. 360. The point of break right here is 360. You got to be careful in going through all the numbers. So the point of break is 360. So in order to go ahead and check that, you could go ahead and use your graph. So this completes the notes for today for lesson 5.1. Let's review the 3 steps. To go ahead and solve a system of linear equations, you need to, 1, graph the equation for both of the linear equations by using the y equals mx plus b format, graphing this y-intercept and then the slope. The second thing you're going to do is you're going to estimate the point of intersection, where the 2 lines meet. The third thing is you're going to take those ordered pairs and you're going to plug them back into each equation. If they work for both, you found the right ordered pair. Thanks. Have a great day.